Okay, welcome to the sum and difference identities. We have a couple of objectives here. I'll be able to use the sum and difference identities to find exact values, and then you'll be able to use the sum and difference identities to change the form of an equation. So we're going to use that for for verifying and some proofs, as well as changing it back to an angle. So you'll see what I mean in just a moment. So I'm just going to give you these identities, and there's plenty of videos on where they come from, but I'm not going to derive them in this video. We're just going to use them. Okay, so here's the first one, and this is just saying if I have two angles, you would think that sine of A plus B would be sine A plus sine B, but that's actually not true. Okay, just like when you look at log equations, it just doesn't work out as you would think intuitively. Instead, sine A plus B would have to be written like this. So we have sine, cosine, cosine, sine, and then the first angle goes in first on both parts, both terms, and the second angle goes in, whoops, I have a mistake right there, second. Let's get rid of that and make that a B. Make sure you pause and write this down before you move on. All right, so we have the sine AB. So what happens when it's sine A minus B? So sine A minus B is going to have the same pattern as far as sine, cosine, cosine, sine. You'll probably notice that I'm singing it a little bit to help you remember. But sine, cosine, cosine, sine is going to happen again. Just like that. Again, A comes first in both. So AA, BB. And what do you think is going to be different? Well, the top one was plus. So this one, where we're subtracting, we're going to put in a minus sign. So sine is the same. Okay, so a couple things to help you remember this or bring this to the front of your head is if you can get the song in your head, sine, cosine, cosine, sine, and then sine is the same. It just matches there. All right, sum of cosines. Okay, so if we have cosine A plus B, well, we have a different pattern here. This one goes cosine, cosine, sine, sine. A still comes first. The first angle goes first in here, and the second angle goes second. First angle, second. Not only is the pattern with the sine and cosine different, but we actually use opposite signs. So cosine, sine, opposite. Okay, so if we come down here and do cosine A minus B, well, it's got the same pattern, cosine, cosine, sine, sine, but the sign in between is going to be plus. There we go, make sure you get that down. All right, sum of tangents. So now we're talking about tangent, some angle plus another angle. And this is going to be tan over 1 plus tan. Except these signs are going to change. Actually, I have this one incorrect. Make this a minus. So tan plus tan over 1 minus tan. Okay, so when you come down here, you can see that the plus here matches the plus here, and this is opposite on the bottom. When we come down here, we're going to keep the tan sign on top, same. Right, so same here, this is the same on top. And then tan sign on the bottom here is the opposite. And hopefully, if you think about this, tan is the same as sine over x over cosine over x. So since sine same, cosine opposite, hopefully that'll help you remember that on top with the tangent, the sign is going to be the same, and on the bottom, it's going to be opposite. Okay, so when you sing this one, tan plus tan over 1 minus tan, you have to change the song when you're doing difference. So it'll be tan minus tan over 1 plus tan. All right, now that you've seen them in the little silly songs, let's actually do some problems with them. Okay, so here's what we're doing with the first objective here. We're going to use a sum or difference identity to find an exact value. So you'll notice that these angles that I'm giving you are not ones found on the unit circle. So if problems if problem is in radians, answer should be in radians. So here we have a couple that are in radians. That means we need to, at the end, if we, well actually, if during the problem we change it to degrees, at the end we have to change it back to radians. So for these, we're going to split up the angle into two angles that are on the unit circle. Okay, so this is not on the unit circle, but if I can find a combination of the numbers 30, 60, or 45 that make 15, remember I can add and subtract angles, that's what we're doing here, sum and difference, then I can use these formulas that I showed you up here to find exact answers for these. So cosine 15, well, I need to figure out if I can add or subtract any of these to come up with 15. So cosine 15 would be the same as cosine 45 minus 30. Okay, so cosine, if you look above on your notes, it's not showing on mine, but cosine is going to be the cosine, cosine, sine, sine. So write in cosine, cosine, sine, sine. And then remember that cosine's opposite, so if we have a negative here, we need a positive here. I'm actually going to put it here so I have room for my angle. And now this first angle goes here, and here, and 30 goes here and here. Okay, well, we don't really care about the, because, or let me say, we're going to be in the first quadrant here, right? Cosine 15 is in the first quadrant. So all I really need are my special right triangles. I don't need to draw the whole unit for this unit circle. So now I just need to use these special right triangles to find the cosine of 45 and the cosine of 30 and the sine of 45 and the sine of 30. So the cosine of 45 is adjacent over hypotenuse, so it's going to be 1 root 2 times the cosine of 30, adjacent over hypotenuse, is root 3 over 2, plus the sine of 45, so opposite over hypotenuse, 1 root 2, whoops, not root 3, root 2. And then lastly, the sine of 30, so opposite over hypotenuse is 1/2. Okay, so this looks like some tricky stuff going on here, but we're actually going to rationalize all the denominators first. So at this step, it's just going to make it a little bit easier here. So root 2, 1 over root 2 becomes root 2 over 2. Remember, I'm just multiplying the top and bottom by root 2. If you're unsure how to rationalize, please come talk to me so we can work on this together. Okay, so everywhere I had a radical in the denominator, I rationalized it. And now I just need to multiply my fractions together here. Okay, I had a 5 here, but I changed it really quick. So when I have two radicals, I can multiply them together. Root 2 times root 3 is root 6. However, I cannot add two radicals together unless they're the same, because they're not like terms. So the final answer on this one, and I'm going to put it up here, is root 6 plus root 2
all driveline students are now dismissed.
all over 4.
All driveline students are now dismissed.
So I can combine it and keep the same denominator, and then on the top, that's as far as I can reduce it. So how would you check this? How would you make sure that you got the right answer? Well, you could use your calculator and find the cosine of 15, and then also plug all this into your calculator and see if they match up. If they match up, then you did this correctly. It's going to be some decimal. That's why I'm looking for an exact answer here, because if you were just to plug this is why we have to use the sum and difference to find an exact answer. Otherwise, you'd have to plug it in your calculator and you would get a decimal. All right, let's give another one a try. Okay, first thing I'm going to do here is change this into degrees, because I think that's going to make this a lot easier for me. So tangent 75. So 75, well, what combination of 30, 60, or 45 is going to give me 75? That would be tangent 30 plus 40. So I have tangent 30, or plus 45, there we go. Plus 45, and then from here it's really just plug and chug and making sure you know how to handle all these radicals. Okay, here we go. Tan plus tan over 1 minus tan tan. Remember, it's the same sign on the top and then opposite on the bottom. And then I'm just going to use my special right triangles to come up with all the ratios for these angles that are on the unit circle. Okay, so I found all the parts that are on the unit circle. Make sure you pause and write this all down. You're going to need all these steps in here. And now I need to use all my fraction and radical skills, my radical skills, to simplify this. So I'm going to first rationalize my denominator. for everything that has a radical. And on that same step, I'm going to go ahead and make this 1 into something with a common denominator with what I end up with here. Okay, here we go. So when I rationalized this, I found that 3 is the denominator, so I made 1 become 3 over 3. I went ahead and multiplied this times 1, and that just gave me root 3, or 1 over root 3, which I rationalized, and that made this 3 over 3. All right, so I can now add now that I have common denominators. Okay, so make sure you get this down. If you're unsure where anything came from here, this is a good place to stop and write down a question so that you can ask me a very specific question in class on anything you're confused about. Okay, so I'm going to take this fraction and divide it by this fraction, which means I'm going to take this and multiply by the reciprocal. So when I visually do this in my head, I'm flipping this one upside down. I guess I'll just write it here, right? So let's say we're going to get rid of all of this, and we're going to end up with the 3 on top, and we're going to end up with the 3 minus square root 3 on the bottom. We get rid of all of that. When I multiply these together, these cross reduce, which then in the end means I have the square root of 3 plus 3 all over 3 minus the square root of 3. Now, is there anything that could simplify here? Well, here I have something matching, but the whole thing has to match in order to simplify. So we're actually done right here. I know this is a messy answer, but that is the final answer to this problem. All right, I want you to go ahead and pause the video and give this problem a try, and then rejoin me when you're ready. Okay, so I change this into degrees. This becomes sine 105, which is the same as sine 45 plus 60. Set up my equation then. Sine, cosine, cosine, sine, and sine the same, so plus. Find them all in my special right triangles. Then I'm going to rationalize the denominator. Here my denominators are all rationalized. I'm going to go ahead and multiply together my fractions, and then I will add them. Okay, there we go. There is our final answer. Okay, that actually I think is the hardest part. Now we're going to move from here and go backwards. So I can see tan minus tan over 1 plus tan tan. Well, this has to be the tangent 1, and now I just have to decide if it's sum or difference. Well, the top is the same. Actually, let's just do this. Tan, and we know it's going to be, the top has to be the same, so it's going to be the minus inside here, and then 22 and 55, and then always simplify, so this would be tangent negative 33 degrees. Let's make sure we put our degrees in there because it is degrees. All right, again, if you punch all this into your calculator and compare that answer to this, it should be the same thing if you did this correctly. Okay, here we go. Sine, cosine, cosine, sine. So we have to figure out which one that goes with. The tan one was pretty easy. Sine, cosine, cosine, sine goes with sine. So this one's going to be sine. So I know it's going to be sine something plus or minus something else. Well, sine is the same sine. So minus, my first angle is pi over 5. And my second angle is pi over 7. And you need to simplify. So find common denominators. Be 35. 7 pi. 5 pi. And go ahead and subtract these. And we get sine of 2 pi over 35. There you go. All right, pause the video. Give this next one a try. Okay, so hopefully you figured this one out, but we have cosine, cosine, sine, sine. So this is going to be a cosine. Sine is opposite, so this negative becomes positive. I have 3x plus 5x. Well, these are like terms, so I'm going to simplify this into cosine of 8x. All right, last thing we're going to do with these is we're going to use them to prove. Well, here's one that we already know. This is one of those cofunction identities. So where did this identity come from? Well, these are two angles here. One we actually have an angle for, one we have a variable for, but we can use that. So we're going to start with this side, the more complicated side, and see if we can get it to equal this side. So sine is going to be sine, cosine, cosine, sine. Sine, same sign, so minus. And then I have pi over 2 for the first angle, and u for the second one, and then pi over 2 for the first angle, and u for the second one. Well, the sine of pi over 2, remember pi over 2 is right here. So this is, the sine would be the y value, which is 1. So now we have 1 cosine u. Well, there's nothing we can substitute in for cosine u because that's a variable. Minus, now cosine for pi over 2. Well, this same spot, what's the x value? The x value is 0. So 0 times sine u. So 1 times cosine u is cosine u. With proofs, always err on the side of providing too many steps. So I'm going to show the step in between here in the very last part. So 0 times sine is minus 0. And then lastly, I have cosine u. So I just proved this because I was able to make this side equal this side. All right, thanks so much for watching, and I'll see you in class.